So here is another question from IIT JEE PYQ. This is one of the most important and it is having some tougher parts in it. It is from the subjective part actually from the year 2000. Okay. So here is the question. In the figure, mass is M1, M2 and this M are 25 and 50 kg. Okay. So here is the situation. This is of M1 of 20 kg here, and this M2 is of 5 kg, and this capital M is equal to 50 kg. Okay. The coefficient of friction between this capital M and the ground is 0. So here coefficient of friction is 0. And the coefficient of friction between this capital M and the ground is 0. The coefficient of friction between this M1 and capital M, that means here at this point coefficient of friction is 0.3, and also between this M2 and the ground is also 0.3, right? The string is perfectly horizontal between this point P1 and M1, right? And also between this P2 and M2 the string is perfectly vertical between this point P1 and P2. Okay. An external horizontal force F is applied to the block of mass capital M, and we have to take G is equal to 10 meter per second square. It is already mentioned there, right? Now our A part is we have to draw the free body diagram of this capital M here, clearly showing all the forces. Okay, so here A part is very easy. We have to draw the free body diagram of this capital M. Let me draw it. This is our block of mass capital M here, right? And this is our ground. Okay, so what are the forces acting on it? One will be the force as given in the question, that horizontal force is acting on this block of mass capital M. Okay, one force is acting in the downward direction, that is equal to weight of this block mg due to the gravitational pull. One force is acting on this block due to this contact surface, contact with the downward surface, that is equal to, let me call it normal force N1, right? And another force is also acting due to this M1 mass, as it is contact here. So one force will be acting in downward direction, let me call it N2. Okay, and these pulleys are connected with it, so there will be some tension force acting on these pulleys. So let me denote it like this. These are the two different pulleys. So there will be tension force acting tangentially to these pulleys like this. Okay, so here are all the forces we have denoted now that are acting on this capital M block, right? Now coming to the second part of this question, we have done our first part here. The second part we have to think about it. Let the magnitude of the force of friction between this M1, this is our M1 here, M1, and the capital M be F1. So here is the friction force F1, let me suppose, okay, and be F1, and that of M2 and the ground be F2. So here is the friction force F2. Okay, for the particular value of F, it is given that F1 is equal to twice of F2. Okay, so it is the situation given in the question that F1 is twice of F2. So here F1 and F2, we have to find out what are these values, and we have to write the equation of motion for all the masses. We have to also find the F2 tension in the string and this acceleration of the masses. So what we have to find here, first the friction force between all the blocks, that F1 and F2, and also this tension in the string we have to find here, and also the acceleration of the blocks we have to find, acceleration of the blocks. Okay, acceleration of the blocks. since let me draw now the free body diagram for these two masses now. Okay, so let me draw a situation here. There is an m1g force acting in downward direction, and there will be a normal force in upward direction due to the contact in surface. Similarly for m2, there will be a m2g force acting in downward direction, and there will be a normal force in the upward direction. Since there is let me call it, this was the normal n1 and this is the normal n2. Since there was not any vertical motion happening in this situation, so I can write here n1 will be equal to m1 into g, and here n2 will be equal to m2 into g. So here I can find out the maximum values of friction that can act in these situations, that is static friction maximum value. So for first block, maximum value of friction F1 max that I will write, that will be equal to mu into n, that will be equal to mu into m1 into g. Okay, so here value of mu is in the question, that is 0.3 multiply the value of m1 is 20 kg multiply this g is 10. Okay, so if we will solve it, it will be this point will be cancelled out, and it will be 60 Newton. Okay, so value of F1 max will be equal to what? 60 Newton. And in the second situation, the value of maximum friction that can act on the second block is what? Mu into n2. So that is equal to mu into m2 into g. So your value of mu is 0.3 multiply the m2, value of m2 is what? 5 kg multiply g is what? 10. So your point will be cancelled out, and the value of maximum friction for F2 for block 2 is 15 Newton. So here F2 max is equal to what? 15 Newton. Okay, so here we have to assume some conditions according to the question. If I assume that like this is our case 1, if I take, let us assume this both particles, both blocks of mass m1 and m2, these both blocks are at stationary position. Both blocks are at stationary position. Okay, stationary position. Since I can see the situation here, if I draw the free body diagram of this m1, like if I am drawing the free body diagram of this m1, then what is the condition here? This is the tension force acting on this body. This is our m1 here, and since this capital M is having tendency to move in the right direction, so friction force on this m1 will also be in the right direction, because friction always prevents the relative sliding between the two bodies. So friction will always try to keep this m1 together with this capital M. So friction force will be acting in this right direction. So this is a free body diagram for this m1, right? Similarly, if I draw this free body diagram for this m2, then this is our m2. I am just writing the horizontal forces here. There will be a weight and this normal reaction also, but I am not considering here. So for m2 also there will be a tension force in the right direction, and along this tension force, since this tension force is trying to pull this m2 in the forward direction, so there will be a friction force acting in the backward direction, that is equal to F2. Okay, so here since this friction is preventing the relative sliding between these two bodies, between the surface and this m2, so it will always try to keep these together at the same place. So friction force will be acting in the backward direction. So I will draw here, this is our situation for m1, this is our m1, and a tension force is acting and a tension force is acting in the backward direction like this, and a friction force F1 is acting like this. Similarly, this is our M2 block, and a tension force is acting in the forward direction, and a friction force F2 is acting in the backward direction. So in case 1 we have supposed that this M1 and M2 both the blocks are in stationary position. So what is that stationary position? That stationary position is like that this tension force, this case first is only possible when this tension force is less than or equal to this F1 max. Okay, because this is only the static condition. If this tension force is either equal to this F1 max or is less than this F1 max, so in that case only this M1 can be stationary. Similarly for this block M2, if this tension force is less than equal to this F2 max, then only this M2 block can be in stationary position. अगर टेंशन की वैल्यू F1 मैक्स से ज़्यादा हो जाती है तो ये ब्लॉक मूव कर जाएगा. ओके, क्रिटिकल कंडीशन को ब्रेक कर देगा, दैट विल ब्रेक द क्रिटिकल कंडीशन. सिमिलरली फॉर दिस M2, अगर टेंशन की वैल्यू F2 मैक्स से ज़्यादा हो जाती है तो फिर ये क्रिटिकल कंडीशन को ब्रेक करके M2 मोशन में आ जाएगा, दैट मीन्स M2 फॉरवर्डली मूव करेगा. ओके, सो हियर इन दिस सिचुएशन F1 मैक्स की वैल्यू अपने को पता है, दैट इज इक्वल टू व्हाट, F1 मैक्स वाज इक्वल टू 60 न्यूटन. Okay, here we had calculated F1 max was equal to 60 Newton, and similarly F2 max was equal to 15 Newton. Okay, so here if I take an intermediate situation like any value of F, if I take this F2 is equal to, let us suppose 13 Newton here. Okay, if I am taking this F1 is equal to 13 Newton, that means our tension is equal to 13 Newton only. So in this case it is given in the question that F1 is equal to twice of this F2. Okay, but if we are taking this tension is equal to 13 Newton, then in that case this tension in this string will also be same. That means for F1 value we are getting that 14 Newton only, 13 Newton only. Okay, this 13 Newton. So हमें F1 की वैल्यू ट्वाइस ऑफ F2 चाहिए. सो ये कंडीशन हमारी सेटिस्फाई नहीं कर रही बिकॉज टेंशन इन द स्ट्रिंग इज सेम एट ऑल द पॉइंट्स. सो टेंशन की वैल्यू 13 न्यूटन अगर हम लेते हैं या 12 न्यूटन कुछ भी लेते हैं तो वो सेम वैल्यू यहाँ पे डेवलप होगा, दैट इज इक्वल टू F1 मैक्स और बिलो देन दैट F1. सो इसमें F1 इज इक्वल टू ट्वाइस ऑफ F2, दैट कंडीशन इज नॉट सेटिस्फाइंग फॉर अस. सो इन दिस केस वी कैन नॉट से दैट F1 विल बी इक्वल टू ट्वाइस ऑफ F2. सो सेकेंड केस अपन अज्यूम करते हैं हियर. लेट मी अज्यूम द सेकेंड केस नंबर 2 हियर. In this case I assuming that this whole of the system is moving in the forward direction with some acceleration. Okay, and this M1 mass, it is here, and also this bigger block is here, and this is our ground, this is our M, and this is a force acting in this direction, and this is the string like this, and this is our M2. Okay, so this system is moving in forward direction with an acceleration a. Okay, so if I draw the free body diagram for all of these bodies, then let me draw first. This is the our M1 here. If it is moving in direction in the right direction with an acceleration a, then there will be a friction force acting on this body like this, that F1 will be some value. Okay, and here a tension force will be acting in the backward direction and the acceleration of this body is in forward direction, that is equal to A. We have to calculate it. Okay, so if I write the equation of motion for this body, then it will be what? F1 minus T is equal to M1 into A. Okay, let me write it like this only. This is our equation number 1 here. And similarly, if I draw the free body diagram for this M2, then this is our M2. This is the tension force acting in forward direction and this is the friction force F2 acting in the backward direction, and it is moving in forward direction with an acceleration A. So if I draw if I write the equation of motion for this body, then T minus F2, that will be equal to M2 into A. So this is our equation number 2. Now if I draw the free body diagram for this, like if I denote the forces in horizontal direction for this M, capital M, so this is our capital M, this is the force acting on this, that F, and there is a friction force due to this block M1, that is F1, acting in backward direction, because friction force always prevents the relative sliding between the two bodies, and there is an acceleration in the forward direction, right? So here if I want to write the equation of motion in horizontal direction, that will be F minus this F1, that is equal to capital M into A. This is our equation number 3. Now if I see this option, question number 2, B part, that for some value of F, it is found that F1 is equal to twice of F2. Okay, so here F1 is equal to twice of F2, it is given. So let me show you here a condition that this is our M2 block here and it is moving in the forward direction and tension force is acting in forward direction, due to which it is moving. So here will be a force F2. If it is moving in forward direction with an acceleration, then what can be the value of this F2? This F2 will always cross the critical condition, that means this F2 will always be equal to the maximum value of friction, that is F2 max. That is what we had calculated here, 15 Newton. Okay, so here F2 is 15 Newton and it is given in the question for particular value of capital F. This F1 is twice of F2. That means twice of this F2, that is equal to twice of 15 Newton, that means 30 Newton. So here the friction value F1 is equal to 30 Newton we are getting, right? So in this equation number 1, if I put these values and I write the equation number 1 again, then what I will be getting here, the value of F1 we are getting is 30 Newton minus this tension force, that will be equal to the value of M1 is what? M1 we had gotten 20 kg and this M2 was 5 kg and it was 50 kg. Okay, 30 minus T, that will be equal to M1, that is 20 kg multiply A. So this is our equation number 1. Okay, similarly if I write the equation number 2 again, then tension minus the value of F2 is F2 max, that is equal to 15 Newton, that will be equal to M2 into A. M2 is what? 5 into acceleration A. So this is our equation number 2. Okay, and similarly if I write the third equation again, then capital F minus this F1 is what here? 30 Newton is equal to capital M is what? 50 into acceleration A. Okay, so this is our equation number 3. Okay, so here we are having 3 equations and we have to find out the values of tension, acceleration of the blocks, and the value of this capital F. Okay, so from equation number 1 and 2, if I add, I will write here, adding equation 1 and 2, I will be getting, this tension will be cancelled out, 30 minus 5, 15, that will be equal to 20 plus 5, 25 into acceleration A. So this I will be getting 15 is equal to 25 into acceleration a, that means 3, this will be 5, so acceleration will be equal to 3 by 5 meter per second square. So this is our acceleration we are getting, right? So if I put this value in this equation number 1, then I can easily get what is the value of tension. 30 minus t will be equal to 20 multiply the acceleration value is 3 by 5. So it will be 4, that means 12. So here tension value we are getting is 30 minus 12, that means 18 Newton we are getting. Okay. So tension value is 18 Newton. Similarly, if I put this value, acceleration value in this equation number 3, then I can easily get the value of capital F, that will be equal to 30 plus 50 multiply the value of acceleration, that is equal to 3 by 5. That is 30 plus 30, that means 60 Newton. So capital F we are getting here 60 Newton. Okay. So here we have gotten all the values. I will write here the friction force acting on this block M1, that is what, 30 Newton. Okay. And friction force F2 due to this block M2 is what, 15 Newton. And the value of acceleration of the blocks is what, 3 by 5 meter per second square. And this capital F value is what, 60 Newton. Similarly, the tension in the strings is what, that is 18 Newton. Okay. So for our question number B, we have calculated all the values here. So this is the way we have to approach this question. This is our strings with tension T. Okay.